All right, so good morning again. Let's get started. Few things I would like to announce is if you have any questions or doubts, please do not unmute yourselves and ask because there is a lecture flow that is going on and I have to stop that flow and answer your question. But what I will do is for after every 5 minutes or 10 minutes, I will say if you have any questions, you may ask now. I will give a pause and ask you and give you an opportunity to ask your questions. So if you have any questions, please hold on to them. And for every 10 minutes, I will give you an opportunity to express your questions. Otherwise, it becomes hard to manage the lecture. So that's number one. Number two is lab 2, chapter 2 problems were released as lab 2 problems, lab 2 programming homeworks. So the submission instructions you will get to know. Don't worry about the submission instructions. We are experimenting a couple of options. Those options will be clear in a day or two. So you don't need to worry about them. That's one. Number two is, so I said Saturday as the deadline, but it's not like really, it's a soft deadline. But what I would like you to do is those students who have trouble solving problems, programming homework from lab 2, you should reach out to the TAs and get their help. And second thing is after today's lecture, chapter 3 problems will be, you should solve. Chapter 3 problems, we will release chapter 3 programming homework. That is also part of lab 2, although it is not released on lab 2 today. Think of it as part of lab 2. So chapter 2 and chapter 3 problems will be released today. So they become part of lab 2 exercises. So all things about like homework submissions, etc., we will communicate with you. Let's not waste the precious lecture time on those issues. But two things I want you to remember. Three things. Number one, if you have any questions, please don't unmute yourselves and ask. I will give you an opportunity to ask the questions. Number one. Number two, chapter 2 programming problems. So if you are not able to finish one or two of them, please take the help of the TAs. They will help you understand the problem. They will help you solve those problems. That's number two. Number three is chapter 3 problems. We will, after today's lecture, we will release. There are 6 problems. Try to solve them over the weekend. Ideally, it will be better if you can solve it before you come to lab 3, because in lab 3, we will release chapter 4 problems. So this is the plan, and let's get started with the lecture. In the last class, we were looking uh, into printf statements and how printf statements work. We will continue the discussion in today's lecture also, followed by that how scanf works. But before we look into printf and scanf, there is one important idea which is not, which is never clearly laid out in C programming lectures, but we will do it. So if you take a C program, your C program is a series of tokens, just like a sentence in an It's an issue from my side. Very unusual that you get a problem from the institute, but it happened. Just give me a minute, guys. Can you hear me? Just wanted to check. All right. So your C program is a series of tokens. An alternate way to look at, later on you will see a much more interesting way to look at your C program is your C program. It is a collection of files. Okay, let me do it this way just for the sake of completeness. Your C program, it is a collection of .c and .h files. That is, your program can be spread across. You cannot see the writing. Here all my drive. Let's Can you see the screen share at least to start with? How about what I'm writing? Oh, it's not working. Can you see now? Yeah. Nice. So your C program, it's a collection of your C program. It's a collection of dots, multiple files. Usually when you write large programs, your program is not present in one file. It's a collection of .c and .h files. And every file, so every file, each file is a collection of functions. Right now you have only one function, main, which is the essential function. Every C program should have a main function, but later on you will write programs where there will be more than one function in your program. And then every function is a collection of statements. And if you see every statement, here it gets a little bit tricky, but for the sake of simplicity, so every statement, so there are some simple statements and compound statements, and every statement, a compound statement can contain statements within. So, but for the sake of simplicity, we can say every statement is a series of tokens. For the sake of simplicity, we say is a series of tokens. Because otherwise a statement can contain a statement. Yeah, so it becomes tricky, but for the sake of simplicity, we can assume that every statement is a series of tokens. So right now, maybe for the next couple of lab sessions, you write programs with only one function in it. Later on, you will write programs with more than function in them. Later on, you will write programs which span across multiple files. So that is how the complexity of the programming homeworks that you do keeps increasing. And if you look at the tokens, so these are the different kinds of tokens you will see: identifiers, keywords, operators, punctuation symbols, constants, string literals. Now let's go to the next. For example, if you see this printf statement, so printf is one token, and its token type is identifier. Printf is an identifier. And left parenthesis, it's a punctuation symbol. And then whatever you have between left and between the double quotes, it is what is called as a string literal. Comma is a punctuation symbol. Again, height is a punctuation. Height is is an identifier. The token type of height is identifier. Right parenthesis is punctuation symbol, and semicolon is also a punctuation symbol. So this is how you can tokenize your printf statement. The interesting thing is the amount of space between tokens usually doesn't matter. Like for example, if you see here, float Fahrenheit followed by comma Celsius followed by semicolon. If you take this program, this is so between Fahrenheit is an identifier and comma is a punctuation symbol. If you can give one or two or many spaces between Fahrenheit and this comma, it really doesn't matter. Similarly, float is a keyword and Fahrenheit is an identifier token. These are two different tokens. The amount of space between these two tokens doesn't matter. Similarly, after hash include, this is space, right? So you can give one space, two space, it really doesn't matter. And if you see, like for example, Celsius is equal to some sub-expression times scale underscore factor, you can have one or more spaces between this right parenthesis and star operator or multiplication operator. Similarly, you can have one or more spaces between. Space means when we say white space, it can be space or it can be a tab or any of these white space characters. And there can be more than one space between star and scale underscore factor. So the spacing between the tokens, it really doesn't affect the semantics of the program because the compiler ignores the spaces and it tries to identify or extract the tokens from your source program. However, if you see the preprocessor directives, you cannot have multiple preprocessor directives on the same line. We cannot have multiple because every preprocessor directive, it should be on the same line, on a line by itself. But you don't want to cram your statements like this as you are seeing in the program here. So it's not readable and it's not useful. So you have to write your program nicely with proper indentation. And spaces, see, if you think of modern programs, you don't get any efficiency by removing spaces in the program, nothing. So the systems are very powerful. You don't see the spaces, they become part of your source code. They don't have any meaning in the executable code. You can have million spaces between int and main. You can have million spaces between int and main, for example. So it doesn't translate to anything in the executable file. But the compiler, while processing your source program, it reads all of them and ignores them. So compiler has to do a bit more effort So when you do proper indentation, the extra spaces and white space characters that you use, they really they don't cause any efficiency problems to the compiler or in the final executable. So you don't need to worry about spaces at all. And within a token type, you cannot have put arbitrary spaces. Like for example, if you take float, float is a keyword, and you cannot write a float as FL space OAT. It's wrong. It doesn't work. Or you cannot split it and then write FL in one line and then OAT starting in another line. Both these things are not allowed. And if you see, if in this printf statement, if you want to, you cannot have a new line character like this. Uh, so within a string, if you want to print a new line character, you know what to do. So you have to use a /n, not press enter in your program. So you have to put a /n just as you did here. You cannot take a string literal and spread it across two sentences. Spread it across two sentences. It's not allowed. Across two lines, it is not allowed. All right, so this is all about the C program layout. So your C program, it's a series of tokens. The space between the tokens really doesn't matter. So it doesn't call, it has very negligible overhead on compiler to ignore these white spaces, and you should not be bothering about it at all. It's negligible means it's negligible. And in terms of the executable, these spaces doesn't have any impact on the executable. It doesn't have any impact on the executable at all because all these white spaces are ignored completely. So if you have a million white spaces, then so these million white spaces doesn't have any impact on your generated executable because all these white spaces are simply ignored. So now if you have any questions, you may ask me. So I will take a pause, and you can either you can type your question in the chat box or you can ask me also.
Sir,
You're all doing good so far?
sir, can I ask a doubt, sir?
So double quotes, they are not part of string literal. They tell what is the actual string literal is. Like for example, here the whole string to see or not to see, that is the question, is the whole string literal, and we whatever that is there in between the double quotes, that is the string literal.
So could you go back to the first slide? I think I missed a few
1 minute.
points.
I think I have to enable the audio on my. Can someone speak now?
Sir, can you hear me?
Yeah,
Could you go
I
back
can
to
speak.
slide 37 for a moment? I think I missed a few points. 37 and
Yes.
38.
37 or 38?
37, 37.
37 is here.
Yeah.
Sir, I had a question.
Okay.
Sir, say I have two different C files with the only difference of extra spaces in one of them. will they
Okay.
give me the exactly identical executable?
Yeah, I think so.
All right.
Yeah. So slide 38. Yes. What's the question, Vivek? So there are two questions. One is Jatin has this question: how many tokens are there in hash include sta.h? It's a good question. So stdio.h. Oh, uh, oh, I understand your questions. I think a hash is a punctuation symbol. Include is a keyword. Left-angled bracket stdio.h is an identifier, and so maybe I'll just write it. So we will not spend too much time on this. That's hash include. As long as you get the idea, because we have more interesting ideas to see. So this is one token. Maybe I will use. So this is one token. This is another token. This is another token. This is another token. And this is another token.
Excuse me, sir.
Yeah.
Sir, could you show one like from all the examples from all the types of tokens on 38? Could you show us a few examples?
Sorry, what is it?
Could you show us a few examples of the types of tokens that you described on page 37?
Yeah. So just now you can look at this hash include stdio.h. It's a statement.
Hmm.
And like for example here hash symbol, this pound symbol, it's a punctuation symbol. Include is a keyword. This is punctuation.
This is keyword.
So include is a keyword. Similarly, left angled bracket and right angled bracket, they are punctuation symbols.
Hmm.
And stdio.h, it's an identifier.
Okay.
So there are some questions on int and float. I will not take those questions in this lecture. I will take them in the next lecture. So let's stick to the discussion of topic of today's discussion. So let's move on and let's look at the programs. Now I would like you to take a look at, we will revisit the printf and scanf and move forward. Great. So we are working with, let's, let me get the terminal. All right. So in the last class, we started our discussion on printf. I want to now show, I would like to show one program, printf ASCII.c. So here we are introducing a new data type called as char. So on line 5, we are declaring a variable as it is of type char, and so a char is allocated 1 byte of memory. So what happens is on line 5, the net effect when the program executes. So like let me use. So this is your. So this is the variable C, and let's say variable C, the address of variable C is 100. So when you see char C is equal to A, then every character, it will be assigned a 8-bit representation in what is called as an ASCII format. We will look at this format bit later, but there is a standard called as ASCII standard for character encoding. So there will be some bit pattern associated, 8-bit pattern associated with character A. I am just putting some random bit pattern, but there is some bit pattern associated with the character A. On line 7, we are printing the character C using 2 format specifiers. So the first format specifier, it treats the contents of the variable C as a character, and it prints it in the character form on the screen. And the second format specifier %d, it treats this particular bit pattern that is present as a integer, and it prints it on the screen. So this is very important. I want you to understand that a bit pattern by itself, it doesn't tell us whether it is an integer, whether it is a floating point number, whether it is a character or anything like that. We are the one who give semantics to it. So on line number 5, in the mental model that we have, we assigned character, whatever the decimal value associated with, or the encoding of the decimal encoding of character A to the variable C. And on line 7, we are interpreting that 8-bit pattern associated that is present in the variable C in 2 ways. Number 1, you interpret it as a character and you print it. Number 2, you interpret it as an integer and print it. So there is a question on repeating. What I'm telling you is, so a bit pattern by itself, it doesn't say anything to you. So if I write an arbitrary bit pattern like 0, 1, 0, 0, 1, 0, 0, 0. So if I ask you what is this bit pattern, so this bit pattern by itself, it doesn't mean anything, because in my mind, I could mean by this bit pattern a character, and someone else, like for example, they may interpret this bit pattern as something else, so on and so forth. So a bit pattern by itself doesn't have any meaning to it. We are the one who give semantics to that bit pattern. So a character will be allocated 1 byte of memory. So C, it will be allocated 1 byte or 8 bits of memory. So %C reads those 8 bits as a character, as Vivek rightly said, and %D read those 8 bits as an integer and prints it onto the screen. Exactly. So now let's compile this program and see what happens. So you can see, so you get A, the value, the decimal value associated with A is 65. And let's say you want to, instead of 65 is not a random value, it is the encoding that is assigned to character A as per the ASCII standard. As per the ASCII standard. So if you see, if you want to print char, let's say C1, C2, yeah, you can see the encoding for capital B is 66. And the encoding for capital A and small a are different. So in C1 we are storing capital A, and C2 we are storing capital small a, and the encoding is different. So the encoding for capital A is 65, the encoding for small a is 97. Yeah, so everything, all characters, everything is assigned an encoding. And so for the time being, we'll just restrict ourselves to ASCII encoding. Later on, we will see something else called as Unicode encoding. So if you have any questions now, you can ask. I'll take pause for a couple of minutes.
Sir, I have a question. Can you
Yeah.
hear me?
Sure, sure.
So what I was asking was, when we are looking at the bit pattern of a character in the integer context, we are getting a particular ASCII value, and we know that we'll get an ASCII value. However, sir, when I look at the bit pattern of a float number in the integer context, we are getting a random value, and we have no way of predicting what value we'll get, right, sir? So, sir, I don't understand
Yeah.
why this is happening.
So good question. We will try to understand it, understand what is happening there later, because we don't have an exact answer to that. Because if you look at the bit pattern of a float and interpret it as an int, some random value should come. It is not coming. We have to see what is going on there. We have to understand that issue. But you have a valid point there.
Thank you, sir.
Sir, when the compiler reads the %C placeholder, so it's just like a queue for it to just look at the ASCII format and then convert it back to the character. And then when it reads it %D,
It's
it
not
converts.
like that. It's not like that. So when the compiler sees %C, it goes and looks at what is the value that is being passed here. You see in the screen at at this position. So at this position, 65 will be passed. So, but 65 will be interpreted as a character, and the character associated with 65 is capital A, and capital A gets printed. In the second case also, this when it encounters %D, it looks at the next parameter, and the next parameter is also 65, but it treats 65 as 65 and prints it onto the screen.
So 65 is not the ASCII form of A, right?
65 is the ASCII form. See, eventually in the computer, what happens is the 8-bit pattern of, oh, sorry, this is, sorry, 90. No, that 65 is the ASCII. It is the encoding for capital A in ASCII form, in ASCII encoding standard, right?
Okay.
Yeah.
So it's stored in ASCII form and it reads from that and prints accordingly.
That's not the right way to think. The encoding for what we are doing is we are encoding capital A using 65. The encoding for in ASCII encoding, capital A is encoded as 65, but it's not actually 65. That is, there's an 8-bit pattern. 8-bit so there will be some 100, 100, something like that it will be there, because finally everything is encoded as bits. So these bits, they will be, when you interpret these bits as a character, you get capital A, and when you interpret these bits as an integer, you get the decimal value 65.
Thank you, sir.
Yeah. So Kishore has a question: how is printf using on %d able to print only 8 bits for a character and 32 for an int? How does it know how many bytes to read? So Kishore, what happens is this 8-bit value, it's a byte, right? It is promoted to 4 bytes. And 8-bit is promoted to 32 bits, and the 32-bit value is computed and printed. That's what happens. There's an implicit typecasting happens. So when it looks at %d and yeah, for all characters, so that 8-bit value, it is promoted to a 32-bit value, which turns out to be the same because it gets zeroed out. All the higher order bits will be zeros. So Amey has this question. So if you are using, if A is given value 65, and if you use, and if there is another number 65, then won't there be a conflict? Yeah, of course there will be a conflict. So you should not mix up things like for example, you could be, so you can have something like int num is equal to 65, and it is your job to, this is the way I would kind of, so don't worry about typecasting, etc. We will come to them later. But what I would like you to do is understand is, so later on we will see what are called as types. So far you have seen character type, int type, float type. So whether it is character, int or float, everything is finally encoded as a sequence of bits. Okay, everything is finally encoded as a sequence of bits. But what is important is, it is your job that when you are operating on characters, you stay in this domain, stay in the respective domains. It is your job. Stay in respective domains. It is your job. You will understand these ideas bit well later on as we keep progressing in the course. So when we jump from one domain to another domain, sometimes it is a safe jump and sometimes it is an unsafe jump. So your job primarily is to stay in the domain in which you are working. You have a bunch of characters. You stay in this character domain and work with them and see that everything is safe. But when we jump from one domain to another domain, then what happens is the same bit pattern will have a different interpretation. And and you better know what is happening there, otherwise you will get into trouble. So similarly, like for example, when you take a 32-bit floating point number and you jump into the int space, the encoding for floating point numbers is different from the encoding from the int space. And something weird can happen when we jump into the int domain by holding the same 32-bit floating point object. So the important thing is stay in the respective domains, respective type domains. And if you make a jump, you need to know that it is a safe jump. You better understand that what you are doing is all right. Are you with me on this at a high level? Let's not worry about typecasting now. So typecasting is when we try to move from one domain to another domain. We will revisit typecasting later. But are you with me till this point? Are you with me? When you are working with programs, there are some variables which are characters. There are some variables which are integers. There are some variables which are floating point numbers. It is always better to work with objects that are within the same domain. All the time work between characters, all the time work between integers, so on and so forth. But when we are making a jump from one domain to another domain, you need to know what you are doing. It may not be a safe thing to do the jump. Great. So, yeah. So now let's look at uh, some escape characters. You have already seen escape characters before, like /n is an escape character. Okay, there are some control characters where you cannot exactly type them. So we call them as escape characters. So here you are using a tab. /t is yet another escape character you are seeing in this program. So let's see what happens when you run this program. /t is nothing but a tab. So tab is equal to some number of spaces, and that number of spaces depends on how you configure your system. Let's compile. GCC escape1.c. So now you can see that how it is printed. After item, there is a tab. So there is this space and unit space purchase. And yeah, so that's all. And then after that, there is a /n, and then there is a tab price, you know, how it works. So this is tab. This is about tab. So tab is one example of a control escape sequence. Let's look at one more program. So you have, many of you have this question that what if I want to print double quote in my program. So whenever you, but quote, you know, it indicates, it's a punctuation symbol, which indicates that the string literally is starting. So in order, if you want to say, you know what, quote is not a punctuation symbol, it doesn't indicate the beginning or end of a string literal. I want quote to be part of the string, then you have to put this / before that quote. So this is how you can escape things. So let's compile this program and see what happens. So now you can see that hello is printed with quotes around because we have kept a quote before that the double quote inside. Let's look at one more program. So you know that / is used as an escape for many, is used as an escape character. What if you want to print /? So you have to use // in order to do it. So this is escape 3. So now you are able to print / followed by /. So this is how you can escape. And some of you have this question, how do I print percentage? Because percentage is also a is used, percentage specifies the start of a format specifier. How do I print %? So the escape character for % is, if you put %, then you will print % on the screen. Yeah, so you can see % is printed on the screen. Are you all with me here? Shall I keep going forward? So there is this question, what will happen if I use / You can see it may not work because the color coding here, it is not, yeah, backslash is not able to escape the percent, so it's not working. Okay, so try it out.
Sir, I had a question just before you. Sir, may I ask?
Yeah, sure, please go ahead.
Sir, I just tried it out on my editor. I basically used the escape for tab, and then in another instance, I just put I just hit the key tab in my string literal, and I printed them both. So even in the second case, the tab is being printed. So, sir, why do we need the escape sequence for tab? Why can't we just use the tab button in the string literal itself?
So I think when your tab got converted into maybe 3 spaces on your screen, because that is how it is set. But when the program is run on someone else's machine, the tab semantics on their machine could be different. But instead of using the corresponding tab semantics, uh, you just print 3 spaces on his machine.
Understood.
Because tab is configured differently in different machines.
So, sir, when we are using /t, it is just using a tab, while when I'm using the tab key, it is considering that as 3 spaces, right, sir?
Yeah, so
That
when
would
you
be the
use
difference.
/t, it is when it is about to get printed on whatever the machine it is, and how the tab is configured on that machine, that particular configuration of tab will be used to print the equivalent number of spaces. But when you just use a tab within the string literal, the configuration that you have within your machine, it could mean 3 spaces or 4 spaces, whatever it is, it will be encoded there. Like for
Understood,
example,
sir.
if I'm using /t here, if you see the code, and then I use just a tab here, and the tab means something on my machine, but it just converted it into equivalent number of spaces. But the first /t is more better, because when this program gets executed on a different machine or at a later point on the same machine, the /t gets interpreted according to how the tab character is configured.
Understood, sir. Thank you.
Great. So now let's look at scanf. All right. So here is an example of a scanf program. So this is a scanf program. We have 4 variables I, J, X, Y, and so remember, for scanf, the important difference between printf and scanf is, in the case of scanf, you want to pass the address of the variables as parameters to scanf, because scanf has to go to the corresponding memory locations and have to update those memory locations So it is important that you pass the address of the variables as parameter, as arguments to scanf function call. And there are 4 format specifiers: %d, %d, %f, %f. And what happens is, so scanf, what it does is, whatever that you type in the keyboard, it will be present in what is called as a keyboard buffer. It will be present in what is called as a keyboard buffer. And scanf tries to match the whatever the characters that are present in the keyboard buffer with this format string, and it prints them, and not it doesn't print them. It as it whatever the values that are read from the keyboard, it assigns them to the respective variables that are given as arguments to it. So let's run this program and see what happens. So you can see the first 2 numbers are integers, the second 2 numbers are floating point numbers. So 2, 3, 2.3, 4.0. So this is how these values are read. So the value 2 is assigned to variable I, 3 is assigned to variable j, 2.3 is assigned to variable x, and 4.0 is assigned to variable y. And so here, if you type them on different lines, it doesn't matter, it will still work. So that is how scanf works. And you can have any number of white spaces between them. You can have tabs. It still works. So that is how the scanf algorithm works. And scanf actually returns, the return value of scanf is number of values which are successfully read. Like for example, let's say int ret value we have here. So scanf returns the number of values successfully read, and we'll say here printf number of values successfully read %d /n. All right. So let's see what happens. Two, 3, 4.0, 5.0. So it will say the number of values successfully read is 4. And let's say if the first character that you, instead of 2, I entered C, okay, 2, 3, 4.0. So what happens is scanf keeps reading the keyboard buffer, and when it sees C, so when it looks at %d, what it tries to do is it tries to find an integer. It scans for an integer in the keyboard buffer. But if it doesn't find an integer in the keyboard buffer, what it does is it immediately returns a failure. So if you see, so now what happens is the number of values successfully read is 0, because what scanf tried to do is it keeps scanning the input, and it scans for an integer to start with. And so when it hits a C, it says, you know what, I hit a C. I'm sorry, I will not be able to consume any more input, and it returns a failure, and it returns whatever the number of values that it has successfully read. So now let's use this 2C, 4.0, 5.0. So now it read the first integer successfully, but it failed at the second integer. So it says the number of values successfully read is equal to 1. And yeah, so that's what it is. Are you all with me here on this example? So the values that you are seeing here, in this case, these are all the values that are correctly set, because the number of values successfully read are 4. And the values of I, j, x, y, they are all garbage values. They are all garbage values. Yeah, so if you type in 3 correct values, it still works. So C, yeah, so C does not.
So can you show the
yeah.
code once?
Sorry?
So can you show the code once?
Yes.
Okay, thank you, sir.
Yeah, so there is one good question. I want you guys to pay attention here. So let's say this is your keyboard buffer. This is your keyboard buffer. And in this keyboard buffer, let's say there is white space character. Let's say I use this as a white space character. And at some point you used C, white space character, to white space character 3, so on and so forth. So when scanf keeps reading this, and when it looks at C, and it doesn't, it is scanf is looking for an integer, but it hit a character. So what it does is it ignores it. Okay, so it says I couldn't find an integer. There is a problem in the input it returns. But what it does is it doesn't consume it. It pushes it back to the keyboard buffer. So next time when you have a scanf for %c ampersand c, then what happens is this character c will be read. Let's say this character is a. So then this character a will be read by the next scanf statement. Are you with me here? Because it doesn't, so this is what it pushes back this character, which doesn't match the input that it is looking for back into the buffer, So it's, yeah, so it's, so, uh, so that the next scanf which let's say the next scanf it wants to read a character, it will be successful. Is there a way to clear the buffer if it fails? I think you can do fflush std in or something like that. So there is a statement called as uh, fflush statement. We will come to that later. Are you with me on the scanf statement so far? I will take 5 to 10 minutes more to conclude the discussion on this. Are you all with me on the scanf?
Yes, sir. Sir, I had a doubt, sir, on the scanf statement. If first we have a failure and then the rest of the characters will not be stored, right, sir? But then again,
Yeah,
on a
that's
new
true.
scanf statement, that buffer, the latest character in the buffer gets stored then, even if we had a failure on the rest of the characters.
So wherever the failure happens, the keyboard buffer is left there, right? So in the next scanf statement, the reading starts from there.
So as in all those failed, the input that failed, all of that will get stored in the next scanf statement, if it is valid.
Yeah, yeah. So that's what, no, like for example, let's see if this is your keyboard buffer. So the one scanf, there are, let's say there is one scanf here and there is another scanf here. So the first scanf failed after looking at the character C. So the keyboard buffer is consumed till this point. So when the next scanf starts, it reads this C and it proceeds further. And this scanf, everything that is there in this scanf, no, it kind of, that's it. Whatever the scanf is out and it's no longer relevant. So the next scanf will start from here, from the keyboard buffer. Does it make sense or?
Yes, sir. So we can have consecutive failures also. If, for example, after C we
Yeah, it
had
is
some more
possible.
data
If
types.
this scanf fails, then again what happens is the keyboard buffer, it will still remain here, for example.
Okay, sir. Thank you, sir.
Let's look at one more code. Yeah, actually this is, let's run this code. So, and if you give space here in between, also it's not going to matter. So the space here tells that, so when you see white space characters in the input, you just ignore them. So the previous scanf with no space between the format specifiers and this scanf both are equivalent to each other. It's not going to change much. But one thing I want to, let's compile this program one more time again, because you will see something weird happening. So let's say -20. This is an example from your textbook. -4.2 E3. So this works perfectly. 1 -20, both are integers. 0.3 is a floating point number. -4, no, 0.0 E3, it is a floating point number in exponential format. It's all good. So this is not so surprising, but let's say if you supply the input like this, 1 minus 20.3 minus 4.0E3. So if you give this, it still works because the way it parses is, it starts from, so it first is your program, your scanner first looks for an integer, and after once it sees minus, then the first integer is read, and it minus indicates that the next integer is starting. So this becomes next integer. And the third format specifier is a floating point number. So floating point numbers, they start with point. So it reads this 0.3 as the third floating point number. And then no, and then this minus the whole thing, it indicates the starting of the fourth argument, that is, which is again a floating point number. So scanf has this involved pattern matching algorithm in it, and so most of the time we don't want to encounter cases such as this, but I just want you to be aware of this. And there are a bunch of questions on trying out different things with respect to scanf. What I would suggest is you should try those things out by yourself and see how scanf is responding. Okay, because I don't have an answer for all those things, but it's a pretty interesting algorithm. Most of the time we want to use it in the simplest way. You want to use this, we want to give inputs also in a nice fashion. So Pallav has a question. Pallav, what's the question?
Sir, in the input that you gave, hello?
Yeah, please go ahead. Yeah.
In the input that you gave, can you show the terminal?
Yeah.
So you gave 1 minus 20.3, then the scientific notation form.
Yeah.
But if I write 1 and minus 2 and 0.3, it would look the same, right? But when we execute the program, the output is shown as 1 minus 20, 0.3 and minus 4000.
Yeah, so you want, if what if my 1 minus 2 0.3, that is the input, right?
Yeah.
Yeah,
Yes.
so see, that's true. What we are saying is it's a valid question. If that is the case, you better give the input properly. You cannot give input no, in a garbage fashion to the scanf, and scanf will do its function according to the algorithm it has. So if that is the input that you want to give to the program, you better give something like this: minus 20, minus 2, 0.3, whatever the value. Okay, let's say 4.2. Your point is very well taken, Pallav. So these cases, these are degenerate cases. You don't want to write programs which take input such as this, because the output of such programs is unpredictable, because the way scanf reads interprets it all, this is all very nuanced thing, and you should never write programs which depend on such semantics of scanf. The simplest thing is all the time separate out the values that you want your program to read, separate them by spaces, and nicely give it as input to the program.
Thank you, sir. Okay.
Good question though, Pallav. It's very good observation. Yeah.
Sir, is there any try-catch program that can be used in C?
No, there is no try-catch in C.
Damn it. Thank you, sir.
No problem.
Yes, sir. I had a
Yes,
doubt.
Ami?
Good morning, sir. I wanted to ask that just in the last part, you wrote 1 minus 20.3 minus 4, all that.
Yeah.
So if I wrote a really long string of just a very big number, the population of Earth, let's say, so it wouldn't know where to break it and start the J function, J integer and all the X integer. It only breaks when it can't read any further, right? So
No, wait a minute. So what happens is, I don't know, it will take the whole characters and then it will possibly modulo of that value would be stored in the number. I don't know. You should try it out and see what happens.
yes, so
Good question, Amit.
it only separates when it can't read any further. Like in the case, if we look at j equals minus 20. Now we know that j can only take integer values. So if it weren't minus 20.3, it would go on reading another value. If there was say minus 20 and then 2, 4, 8, 9, if it were continuing, it would have continued until it couldn't interpret any further, right?
No, I understood your question. I understood your question that it keeps on going and it takes all the characters and tries to interpret it as an integer. But what exactly happens internally in scanf, I don't know. I think you should try it out and see what happens. I don't know. It's a good question. I understood your question. Let's say even if you're reading just one integer, and if you give a very long integer like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blast, something like that, huge number, then what happens we have to see. Try it out
Yes.
and you should and
Yes,
tell
sir.
me what happens.
Yes, sir. Thank you, sir.
Good
Sir,
question. Yeah.
sir, you put like the input you gave 1 minus 20, then 0.3 and minus 4,000, right, sir?
Yeah.
Sir,
Yes.
if we go back to the code and remove like j, like the integer j, will we get 1 minus 20.3 and minus 4,003 values like that?
If you remove minus, if you remove
J, sir, like
j
from the
there,
code. Yeah, if we
okay.
remove j.
Okay, got it. Yeah, of course, I think it will happen. Minus 20.3 minus, I think so. Your observation is right. I think that's what will happen. Good. So there are two questions before. So I think we should move on because there is one idea that I would like to cover, which will help you in solving the homework problems. So this is what, so there are two interesting questions being asked. So like for example, the question by Ame, like you are trying to read an integer, but you gave a very long, very big integer. And what happens? How scanf responds? I don't know. You should try it out and tell me what happens. Very good question. Second question is what Sushil asked you just now. So for the same input, the way we have given the input on this line, if in this scanf statement, if I replace the second integer, how this second integer percent, this is ampersand j and percent d, how scanf interprets that input. These are very two nice problems which I recommend all of you would should try it out after the class and see what happens. Good. So let's move on because as I said, yeah, this is an important example and this example helps in this example helps in doing the homework problems. So here you can see that there is percent d divided by, there's a forward slash percent d. So what happens is when scanf looks at percent d, it keeps looking for an integer in the keyboard buffer. Once it gets a digits, it reads them, and after it reads them, so let's say this is your keyboard buffer with 4 to 4. So when it hits percent d, it starts reading these characters 4 to 4, and then when it and then after that, what it tries to do is it tries to match the forward slash that is present in this string to be there in the keyboard buffer. And if it doesn't match, then it emits an error. And after this forward slash, it moves to the next percent. And when it looks at the next percent d, it is all right to have spaces in the input. Whenever scanf looks at a percent d, it ignores the white space characters until it hits the next input which matches the format that is being specified. So let's try to read. So this particular example I really like because I actually learned it a couple of days back because I never used this feature before in scanf, but it helps in nicely entering the rational numbers as input. GCC scanf2.c, you run it. So 3 by 4, so it prints 3 by 4. So it reads 3 into 4 and into I, and it reads 4 into j. But on the contrary, if I don't have that backslash, then like 3 is successfully read into variable I, and since there is no backslash in the input stream, so scanf fails there, and it returns back with saying that I am able to read only one argument, one input. So that's what scanf does. So there are, in the homework problem at the end of chapter 3, so there are few programming problems which use this particular feature of scanf, where the input is read in some format and you want to print the input in some other format. Yeah, this is the code. You can see the code. So let's explain. So the simplest case of input is this. So 3 is read into variable I. This slash is matched with the slash that is forward slash that is present in the scanf. And then this 4 is read into variable J. And there are two possibilities. There are two possible ways. When you say 3 forward slash divided by 4, it still works, because what happens is what scanf does is after it reads 3, if you give, there are 3 inputs. Case 1 is the simplest case. In this case, this will be read to I, this will be read to J, no problem. This is case 2, is also not a problematic case. There is a space here followed by 4, in which case scanf reads 3 and stores it into variable I. It matches this forward slash in the keyboard buffer with the slash that is present here, and it is happy about it. And then after that it looks at %d, and then once it looks at %d, it starts looking for an integer, and if there are any white space characters in between, it ignores them. So this also works fine, because 3 will be read into I and 4 will be read into J. When we print it, it still works. Case 3 is a problematic case. Case 3 is if I say 3 space 4 like this, then this is a problematic case, because after reading 3, scanf immediately expects a backslash, but it is not there. So it will say, no, like it will not be able to read 4 into variable J. This is a problematic case. And in order to handle case 4, if you kind of put no space here, then this space will be matched. Then the space here will be matched with the space here, and the case 3 will also be handled. So this is the discussion about scanf. I know you may have a few questions, so you should read the textbook and get these ideas clarified if you have any more questions. And the homework problems that are there at the end of the textbook, they really help you out in getting a good understanding about how scanf works. So I think with this, I'll conclude today's lecture. Let's see, I have one more program. I'm not sure what that program contains. Yeah, it's okay. I think we are good. All right, so let's conclude today's lecture here. Stop.